Welcome to our first Arduino lesson. To get started, we're going to be using a software called Tinkercad to simulate various circuits. Now this is what will happen once you first log into Tinkercad, and we're going to switch into circuits. And to get started, we're going to make a new circuit. This brings up a new page where we have access to a bunch of different components. We can access code, and there's a drop-down menu to allow us to select different options. For our first circuit in this lesson, we're going to be making a simple circuit that consists of 4 components: a battery, a resistor, a switch, and an LED. And the way this circuit is going to work is by flipping the switch on and off, we're going to be able to turn the LED on and off. Now let's get started. First, we're going to go to the Components tab. Right now it's under Basic. We're going to switch it to the Starters and go to Basic. This brings up some circuits that are already made consisting of some basic components. And we're going to be selecting the LED switch circuit. You can see it right here. Now, right here we have the battery, which is 3 volts. We have our switch right here, which will be able to flip on and off. We have a resistor and the LED. In order for the LED to turn on, electricity must flow all the way through the one side and out the other. It's also important to note that this side of the LED must be connected to negative, and this side must be connected to positive, otherwise the LED won't work. And this resistor is in here to lower the voltage so that the LED doesn't explode. Now that we have our circuit all set up, let's actually see how it works. And to do this, we're going to hit the Start Simulation button right here. And now the circuit should be able to work. So we're just going to click the switch. You can see the LED now turns on, and we turn this off, it turns off. And this is one of the most basic circuits that shows how electricity can flow. This could be one of the building blocks of all the other circuits we're going to make in this course. Now that we've completed our first circuit, it's time to go on to our next one. And to do that, we're going to click on the Tinkercad logo up here in the top left, and this will bring us back to the dashboard. We're just going to click Create New Circuit. Now, the next circuit that we're going to be building is very similar to the last one. It's going to be an LED dimmer. And in this case, the only difference from the last circuit is that we're going to be using a potentiometer to adjust the brightness of the resistor. Now let's see how this works. So we're going to go to the Components tab. Again, we're going to go to the Starters and Basic. Then we're going to select LED dimmer. We're just going to drag it on the screen and click to place it. Now the components that we have here, once again we have the battery, the LED, and the resistor. But this time we have right here a potentiometer. And this is actually a resistor, but we can change the value of it by spinning it. And this will change the amount of current that flows through the LED, and overall, this will cause the brightness of it to either increase or decrease. Alright, now that we have the circuit all set up, let's simulate it. We're going to do it just like the last circuit, and let's see how this affects the LED. So right now, no light is on it. This must mean that the potentiometer is all the way in the off state. Now let's start to turn it and see what happens. You can see very faintly that the LED is turning on now. Let's keep going and see. Now it's getting even brighter. Now the potentiometer is all the way on and the LED is as bright as it gets. Now as we turn it back down, we can see that it starts to get darker as well. Back all the way to the off state. This circuit now shows another way that how we can control an LED, and this is using very simple components known as analog components. However, in the rest of the circuits we're going to use, we're actually going to be using a much different approach. Now we're going to move on to the final circuit in this lesson. We're going to go back to the dashboard and create one more circuit, and this time we're going to be using an Arduino circuit. So we're going to go to Components, Starters, Arduino, and we have a bunch of different options here, but for now we're going to start with the Blink circuit. I'm just going to drag it onto the screen and click to place it. Now this has only 3 components. It has the Arduino, which is a microcontroller, and this is a microcontroller that we're allowed to program to be able to do different functions, and it has various different pins that we can connect components to. It has digital pins right here, has some analog inputs, and then it has some power ones such as ground, 5 volts, and 3.3 volts. Then we have the resistor and the LED once again. Since the Arduino can be programmed, let's click on the Code tab. This brings up some block coding, and you can expand the screen a little bit so you can see a little bit better. So this program has a few different components. It has comments, which explain what the code does. It has some blue functions, which are changing the pins, and then it also has some wait functions. These wait are simply just pausing the program for 1 second, and the blue codes here, these are turning the pin on and off. And as you can see, the title block is saying what this program is doing. It says the program blinks pin 13 of the Arduino. So we can see it's going to set the LED to on by setting it to high. It's going to wait 1 second, and then it's going to set it to low, which is turning it off, and then it's going to wait 1 second. And this is going to repeat over and over again. Now that we understand the code, let's now see how the circuit actually works. So we're going to close the Code tab, and we're going to click Start Simulation. You can see the LED is flashing on and off, and so is this little LED that's built into the Arduino right here. And this is because we're setting the built-in LED, which is also connected to pin 13. So by doing this function here that says set built-in LED, we're not only controlling the LED on the Arduino, but also pin 13. And we can see that it's turning on for 1 second and turning off for 1 second. Now that we can see that the circuit is working, let's try changing the code and see how everything will react. Now before we can do this, we need to stop the simulation. So just click Stop Simulation. You can see that the USB is now unplugged from the Arduino, and now we can actually change the code. So in this circuit, there's really only two things that we can change. We can change the wait time for when the LED is on and the wait time for when it's off. So let's start by changing this so that the LED is on for 3 seconds and off for 1 second. Let's see if this works properly. So we're going to simulate it. Now we can see the LED is on, and now it's off, and now it's back on already. So the LED is on for longer and it's off for much shorter. Let's try changing it the other way now. So we'll stop the simulation. We'll change this back to 1, and then we'll change this up to 3. Now when we hit Start Simulation, LED it's on for much shorter now, and it's off for a much longer time, as we can see here. We could even change it again so that they're instead both on for 3 seconds. So we'll start the simulation one more time and see what happens. The LED is on once again, and now it turns off, and it's off for an equal period that it's on, which is 3 seconds. So the circuit is working just as we expected it to. Now that we've built these 3 circuits, we've learned some crucial tools. First, we've learned how basic circuits work and how current flows, and how we can control this using a switch or a potentiometer. And now, in this 3rd circuit, we've now used the Arduino, and we've learned how we can program the Arduino to control an LED. However, the Arduino can do a lot more than just control an LED. It can control motors, sensors, and all different types of different electronics. And we'll see more of these devices in future lessons.